नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार द्विशेट्टी, फैकल्टी ऑफ माइक्रो प्रोसेसर्स। मैं आप सब लोग को यहां स्वागत कर रहा हूं। आज हमारा लेक्चर है माइक्रो प्रोसेसर्स यूपीएससी मेंस का। लास्ट क्लास में हमने माइक्रो प्रोसेसर्स का क्वेश्चंस कैसे तरीका हो सकता है, इंट्रोडक्शन टू 8085 माइक्रो प्रोसेसर पूरा हमने डिस्कस किया था। एंड 8085 में इंस्ट्रक्शन सेट के बारे में कुछ डिस्कस किया था। एंड 8085 इंटरप्ट्स के बारे में भी हमने डिस्कस किया था। सो आज का कंटेंट हम थोड़ा सा आगे बढ़ जाएंगे, 8086 माइक्रो प्रोसेसर एंड 8051 माइक्रो कंट्रोलर पर भी चर्चा करेंगे। ओके, सो दिस इज अवर सब्जेक्ट। मेंस में आपको बहुत अच्छा वेटेज आने की चांसेस है। सो आज हम डिस्कस करेंगे 8086 माइक्रो प्रोसेसर बेसिक्स। सो प्लीज कीप द हेडिंग एज 8086 माइक्रो प्रोसेसर. So first of all, if you see the 8086 microprocessor basics, some basics point here, you can ask you some basic features of 8086 microprocessor. So first of all, it is a third generation microprocessor. It is a third generation microprocessor. That's the first point you can write. And 8086 microprocessor having data lines 16-bit data bus, 16-bit data bus, and it is also having 20-bit address bus, 20-bit address bus. 20-bit address bus, and you can access up to 2 power 20 memory locations. 2 power 20 memory locations. 2 power 20 memory locations means what is the range? The range starts from 5 zeros to 5 Fs. So this is the range, 5 zeros to 5 Fs. Okay, so this is our range of the memory. That is the range of the memory. So 2 power 20 means one memory location can store 8 bits. So 2 power 20 into 8. So that I can take it as 1 megabyte. 1 megabyte. Okay, so please note down these key points. So, and we will discuss. So as I told you, so this is a scenario. 8086 microprocessor is having 16 data lines. They are D0 to D15. 20 address lines. They are A0 to A19. So A0 to A19 I can take like this, A0 to A19. So all zeros and all ones. So this is F, this is F, this is F, this is F. This is a total 5 Fs. Okay, 5 Fs. So please note down. The range note कर लो यार. See here, 20 address lines, so 2 power 20 memory locations. So if you have 20 address lines, you can go up to 2 power 20 memory locations. 2 power 20 memory locations means 1 megabyte. Next, so if you see this, the pin diagram of 8086, there are basic pins. The most important pin here is the MN by MX bar. Pin number 33 actually this is. MN by MX bar. So MN by MX bar is the actual pin which decides the minimum mode and max mode operation. MN by MX bar is the actual pin which decides the minimum or max mode operation. If MN by MX bar is connected to VCC, then it will work like in minimum mode. If MN by MX bar is connected to ground, it works like a maximum mode. Maximum mode. So this is a minimum mode of operation and this is a maximum mode of operation. Okay, so this is minimum mode and this is the maximum mode. So if you see the total lines of address and data lines, as I told you, we are having 20 address lines and 16 data lines. So in this 16 will be clubbed with the address. So that's why we are having here AD0 to AD15. So AD0 to AD15 here up to this. So AD0 to AD15. So AD0 to AD15, they're combined with address and as well as data A0 to A15, D0 to D15. Similarly, the remaining status lines A16, 17, 18, 19. So 16, 17, 18, 19, they are clubbed with the S3, S4, S5, S6, S3 to S6. Okay, so these are the major things, my dear. Chalo. Now, I want to just introduce you some supporting peripherals of 8086 related. So, what are the various supporting peripherals, especially in 8086 microprocessor? He may ask you what are the various supporting peripherals which we have to attach to interface. So, if you see that 74LS373 is the address latch. Okay, so this is one thing. So, next 8284 is a clock generator. 8284 is a clock generator. Okay, 8284 is a clock generator. Next, 74LS373 is an address latch. 8286 is a transceiver. 74LS138 is a decoder. 8255 is PPI, parallel peripheral interface. 8237 or 57 is called as a DMA controller. And 8259 is called as PIC, priority interrupt controller, my dear. And 8279 is called keyboard interface. And here if you see 8251, that is a UART, and 8253 or 54 are called the timers. So these are the various supporting peripherals required. When you attach these peripheral chips, these individual chips to the microprocessor, it will forms like a microcomputer. Okay, my dear students, that is a point, note down. So these are the various peripherals. Now let us start first some pins diagrams. So generally the frequency of the crystal that we are taking here is frequency of the crystal, whatever that we are taking. So this is the frequency of the crystal. So the frequency of the crystal is 15 megahertz. So this is just, let us make a correction here. That is small is given print over there. So this is a frequency of the crystal is 15 megahertz. So when it is divided by 3, we are going to get 5 megahertz. Here 5 megahertz. Just a second. So what I want to convey here is the frequency of the crystal. If I am taking the frequency of the crystal is 15 megahertz for 8086 microprocessor, 15 megahertz. So the frequency of the crystal is divided by 3, then I am going to get 5 megahertz. So frequency of 8086 microprocessor is 5 megahertz. Frequency of 8086 microprocessor is what? 5 megahertz. So there are different versions. 8086, one version is having 10 megahertz. 8086, two version is having 8 megahertz. But this 8086 is having 5 megahertz. Next, frequency of the crystal is 6.14 megahertz. So when it is divided by 2, I am going to get 3.07 megahertz. So please make a correction here. So this is 3.07 megahertz. This is 3.07 megahertz. 3.07 megahertz. So this is a frequency of 8085. So 3.07 megahertz. Okay. So frequency of the 8086 microprocessor is greater than frequency of 8085. 8086 microprocessor frequency is very much greater than 8085. So that's why if you see the time period is equal to 1 by f, I am going to get 1 by 5 10 power 6, that becomes 0.2 microseconds, and this is 0.3 microseconds. So time period is less here. That means 8086 is faster than 8085. 8086 is faster than 8085. So please make a note of these points. Now, as I told you, the modes of operation of 8086 microprocessor. So modes of operation of 8086. The modes of operation of 8086. The modes of operation of 8086. So 8086 is working in two modes. One is the minimum mode. One is the minimum mode. Other one is the maximum mode. So this is a minimum mode. This is a maximum mode. Okay. So minimum mode and maximum mode. If you see, this Mn by Mx bar is connected to VCC. This Mn by Mx bar is connected to VCC. Mn by Mx bar is connected to VCC. Then it is called minimum mode. If Mn by Mx bar is connected to ground, my dear, it is connected to ground like this. Mn by Mx bar is connected to ground completely. Okay, so then that is called maximum mode. Okay, so in minimum mode, it acts like a uniprocessor system, my dear. In minimum mode, it acts like a uniprocessor system. Uniprocessor system means it can perform only one task at a time. Okay, whereas in here, maximum mode, it acts like a multiprocessor system, so it can work like a multitasks. So multiple task means what? Along with your 8087, so there is another processor is required. So that means whenever you are performing multiple tasks along with you, there is another co-processor is required, 8086 and 8087. So 8086 is your actual processor, and this is what we call as numerical co-processor. So what we call this as numerical co-processor. Math numerical co-processor. So this is the actual main processor. So please make a note of these points. Please make a note of these points. Done? Chalo. Now let us discuss the pins. So if you see these pins, these are the minimum mode pins and maximum mode pins. So pin number 24 to pin number 31, you can check. Pin number 24 to pin number 31. So these are the minimum mode pins. So these are the maximum mode pins. So these are the minimum mode pins. So these are the minimum mode pins. These are the maximum mode pins. Okay, so let us see now in detail how they will work. Okay. Now if you see, as I told you, the total 8086 pins can be taken like this. So please make a note, 8086 pins. 8086 pins can be classified as common pins, minimum mode pins, and the maximum mode pins. Okay, so same pin number 24 to pin number 31, they are common mode pins. So that is defined as Mn by Mx bar. So when the pin number 33, just before I told you pin number 33, which is Mn by Mx bar, which is connected to VCC, and this one, if it is pin number 33, Mn by Mx bar is connected to ground. Okay, so these are the minimum mode pins, maximum mode pins. So common pins are AD0 to AD15, NMI, non-maskable interrupt, INTR, clock, ground, A16 to A19, S3, S6, BH by 7, Mn by Mx bar. And next, these are 24 to 31 if you see now in INTA bar, ALE, DN. So let us go through every step. So first let us talk about the minimum mode pins. If you see the minimum mode pins, the first pin comes as a DT by R bar. So as the name indicates, the data bus can be working in transmit mode and receive mode. So DT by R bar, if DT by R bar is equal to 0, it is working like a receive. If it is 1, it is working like a transmit. See here. So 8086 microprocessor is having data bus and address bus. So the data bus functionality has to be told first, whether the data bus has to access the data or whether the data bus has to write the data. So data bus has to in a mode of reading or writing. Somebody has to initiate this. So that is happening by this pin. If DT by R bar is equal to 0, so this bar is there. Bar means logic low. So when this is equal to 0, now the data bus is in receive mode. The data bus is in receive mode. And DT by R bar is equal to 1, then data bus is in transmit mode. This is in transmit mode. So try to understand, DT by R bar is equal to 1 means data bus is in transmit mode. DT by R bar is equal to 0 means data bus is receive mode. So 0 means this will be activated because it's an active low signal. This is an active high signal. For active high signal सर के ऊपर बार नहीं रहता. R bar है तो वो active low signal है. That means उसको 0 देने से वो active होता है. So when you give 0 now this will be active. When you give 1 now this will be active. So try to understand this. So when you give 0, the receiving section is going to be activated, then the data bus is going to receive the things. When you give this 1 now, then the transmission section is going to be activated. Okay, chalo. Now let us go for this M by IO bar. So M by IO bar means memory by IO bar. So as I told you, 8086 microprocessor can access the things from the memory as well as the IO devices. Suppose if M by IO bar is equal to 1, it is going to access from the memory. If M by IO bar is equal to 0, it is going to access from the IO devices. So 8086 has 20 address lanes, it can access 1 megabyte memory. So on memory it can perform the read operation it can perform, and write operation also it can perform. On IO device also it can perform the write operation and it can perform the read operation. But how it is going to happen? So if M by IO bar is equal to, if M by IO bar pin is equal to 1, this section is going to be activated. If m by IO bar is equal to 0, and then this section is going to be activated. So please make a note of these things, my dear. Now let us see here how it will be working. See here, see the combination. So this is a dt by r bar, this is a m by IO bar, this is a read bar, this is a write bar. So dt by r bar is equal to 0, m by IO bar is equal to 0, read bar is equal to 0, write bar is equal to 1. So if m by IO bar is equal to 0 and this memory read operation karna hai, so memory read operation means this should be 1. M by IO bar must be equal to 1. First of all, it is a read operation, so dt by r bar must be 0. Data bus should be in the read mode. Next, it is a memory read operation, so m by IO bar must be 1. It's a read operation, so it should be 0. As the read operation, write bar should be 1. Next, memory write operation. So first of all, it's a write operation. So write operation means dt by r bar must be 1. And it's related to memory operation. So memory operation means it should be 0. So its memory related operation means it will be 1 actually. So this should be 1 here. Got it? And it is write operation. So write bar is equal to 0. The read bar must be equal to 1. Next comes IO read operation. So DT bar, it's a read operation. Say read operation. So you have to read from the IO device. So M by IO bar must be 0 here. So please make a note of these points. Some mistake here. Correction kar lo. So this must be 0. And this must be 0. And read operation. So data should be in the read mode. And write operation should be 1. That's fine. And it's a read operation. Read bar must be 0. Write bar must be 1. And it's a write operation. So write bar must be 0. Read bar must be 1. Chalo. Noted now? M by O bar is equal to 0 means memory related operation. Okay. It's wrong actually. It's completely wrong here. Whoever is writing this. See. M by I O bar is equal to 1 means memory related operation. M by O bar is equal to 0 means IO related operation. Make a note of this. Okay. That's it. Next. Now we are talking about the pins of this. So we have covered these pins, right? DT by R bar we have covered. So we have covered the DT by R bar and this M by IO bar. DT by R bar and M by IO bar. Next, let us go for hold and hold acknowledge how these pins will work. Let us see this hold and hold acknowledge how these pins will work. So now if you see the 8086 microprocessor hold and hold acknowledge how they are going to work. So this is a 8086 microprocessor. See, suppose if you have an external device, this device is having certain data to transfer to the memory. This device is having certain data to transfer to the memory. But every time this device wants to transfer the data to the memory, it needs the permission of the bus. It needs the permission of the bus. Okay, it needs the permission of the bus. So what I can do here, so every time this device has to send a request signal to the microprocessor, and the device has to wait until the bus becomes free. And even though bus is given to this device, that will be only for a moment of time. Immediately again the microprocessor demands the bus, again the switches have to be thrown back. Again the switches have to be thrown back to this. So again only device has to send a request signal, again it has to wait. So it's a vicious process, it goes on taking time. So if you see this DMA controller is assistant between this microprocessor and this fellow. So first it will send a request signal and this DMA controller will send a hold signal, and in return we are going to give hold acknowledge signal. Okay, and here we are going to give an acknowledge signal. Then the bus is given back to the DMA controller, and the DMA controller will communicate with the device and the data transfer will take place. Okay, so please make a note of these points. Chalo. Noted. So microprocessor can deliver when the bus is free. Microprocessor can deliver bus as free only at instruction execution stage. Microprocessor can deliver as bus as free only at instruction execution stage, my dear. Okay. Chalo. Now this is our situation. So every time whenever the device wants, so it can take the request signal. The request signal dene ke baad DMA controller will send a hold signal. I want to hold your bus. When the microprocessor is free to give the bus, it will give acknowledge signal. Once the acknowledge signal comes, the bus, address bus, data bus, control bus switches are given to the DMA controller, and from that again the DMA controller will access the device and the data transfer will take place between this device and memory, my dear. Okay, so that's how hold and hold acknowledge will work. Okay, so that's it. Next, let us go for the important pins like maximum mode pins. So in maximum mode, what are the major pins? If you see in the maximum mode, there are certain famous pins. So these are the famous pins: S0 bar, S1 bar, S2 bar. So if you see this, how this S0 bar, S1 bar, S2 bar will work. See this. Please make a note how these things are going to work. Maximum mode pins. For every status, there is a repetition of operation. So see here. So 0000 is the interrupt acknowledge. Next 001 is the IO read. 010 that is the IO write. 011 that is a halt. 100 that is called instruction fetch. 101 that is called memory read. 110 that is called memory write. 111 that is called inactive. Okay, so these are the various operations. So next comes here request and grant. So request and grants are similar to like hold and hold acknowledge. So request and grant, suppose same like X device wants to access the bus, you will send a request signal, then get the grant. And the Y device, it will give a request signal, then get the grant. Like this. Suppose both the devices are accessing first. Request and grant is there for this, request and grant for that also. So both the devices are giving the same time. So then this will be having the highest priority. It's just like in minimum mode we are having hold and hold acknowledge. In the same way request and grant things will work. So next another one is a queue status. So as I told you in 8086 microprocessor we are having a queue status. There is a queue 6-byte queue. Okay. So queue status means QS0 and QS1 both are 00. There is no operation, queue operation. 01 means first byte is fetched. 10 means empty. 11 means subsequent byte. Okay, 6-byte queue. So this is a byte 654321. So queue works in first out format. Queue works in what? First in first out format. Queue works in first out format, my dear. Whichever is comes first. Actually, this is the queue operation. So queue will be like this. Queue will be like this. So this is 1, 2, 3, 4, 5, 6. 6 bytes. Okay, 6-byte queue. So whichever is first now, that is exit. Like this it will go. First in, first out. So now which byte is getting access, that is decided by this. If both are 00, no operation on the queue. 01 means first byte is going to be fetched. 10 means queue is empty. 11 means subsequent. So please make a note of this point. What is happening is a marathon session only, na Shivansh? Shivansh, sir, please bring a marathon session for EEE with PYQs. Acha, for PYQs, for electrical engineering. Okay, you're asking for electrical engineering. This is only for ECE you're thinking. Okay, okay. Almost same rahega, bhaiya. Shivansh ji, almost there will be same content will be there. Shivansh, have you qualified the prelims? Okay. Almost same content. You can use this almost the same. Electrical maybe almost same questions rahega. Okay. So please note down 8386 microprocessor का Q का operation ऐसा रहता है. So next let us go for, first of all, to understand this 8086 we should know the block diagram. So this is a block diagram of 8086. So 8086 block diagram contains two blocks, BIU and execution unit. So one is the bus interfacing unit, other one is the execution unit, my dear. So this is bus interfacing unit. What is this? This is what we call as bus interfacing unit, and this is what we call as execution unit. This is what we call as execution units. So BIU and execution. So in BIU we're having these things: code segment, data segment, stack segment, extra segment, instruction pointer. Okay, and these are the registers AX, BX, CX, DX. As I told you, these registers are divisible as AH and AL, microprocessor registers. BX, CX, DX, these all are divisible registers. Okay, so now if I see here, this is BH, BL, CH, CL, DH, DL. These are stack pointer, base pointer. These are source index and these are destination index. Chal raha hai. Next, these are code segment, data segment, stack segment, extra segment, and this is IP. IP stands for instruction pointer. Okay, so this stands for instruction pointer. Instruction pointer. Okay, so what the bus interfacing unit will do? So there is a memory like this. So there is a memory like this. So there is a memory like this. So from the memory it will fetch something and will place in the queue. From the memory it will fetch something and will place in the queue. So the queue is a 6 byte now. So how to go to that address, where from it has to fetch, that is all done with the supporting of this register CS, DS, SS, ES. It will go to the particular registers. It will go to the particular content of CS and it will go to the IP. CS and IP both are added, and from this it will go to the memory. From the memory it is going to take the instructions and placing them in the queue. So now one by one it is going to fetch and is going to place in this. Okay, so now, so this execution unit, in the execution unit we are having the only execution part. So it will take the instruction from the queue and will go on execute the things. It will go on execute the things one by one. It will go on executing the things one by one. Okay, so one is a bus interfacing unit, other one is the execution unit. And so what actually is happening here, while execution unit is executing one instruction, the bus interfacing unit is fetching the other instruction and placing in the queue. Okay, the bus interfacing unit is fetching the other instruction and placing in the queue. So this technique is called as pipelining. So what we call it as pipelining. See here bus interfacing unit is going to the memory. Bus interfacing unit is going to the memory, and from the memory it is fetching something and placing in the queue, and then EU is coming and taking that byte and executing. While you are executing this byte now, this bus interfacing unit taking another byte and placing in the queue. So what we call it as, while execution unit is executing a byte from the queue, the bus interfacing unit will be prefetching the next instructions and places them in the queue. So this speeds up the process. And this technique is called pipelining. So prefetching the next instruction while the present instruction is under execution. Prefetching the next instruction while the present instruction under execution is called as pipelining. So इसको हम क्या बोलते हैं? Pipelining बोलते हैं. So what we call this as pipelining. Pipelining means prefetching the next instruction while the present instruction is under execution. Prefetching the next instruction while the present instruction is under execution. Please make a note of this. One of the important questions this is. While execution unit is executing a byte from the queue, the bus interfacing will be purchasing the next instruction and places them in the queue. This is what we call as pipelining. उसको क्या बोलते हैं? Pipelining बोलते हैं. चलो. Now let us see the registers of 8086 once again. So if you see the 8086 registers, 8086 register code segment, CS is a code segment register, that is a 16-bit. DS is a data segment register, that is a 16-bit. SS is a stack segment register, that is a 16-bit. ES is an extra segment register, that is a 16-bit. So we are having the code segment register, data segment register, stack segment register, and extra segment register. Code segment, data segment, stack segment, extra segment. So AX is the accumulator 16-bit, BX is the base register 16-bit, CX is a count register 16-bit, and DX is the data register 16-bit. Okay, so these are the accumulator. So we are having the things here: AH, AL, BH, BL, CH, CL, DH, DL. Okay, so these are the things: AH, AL, BH, BL, CH, EL, DH, DL. So please make a note of these points. Code segment register, what it will do? CS register, what it will do? It will hold the 16-bit address of the starting segment. See here, it will hold 16-bit starting address. STM in starting address. STM in starting address of code segment. Next, data segment will hold the 16-bit starting address of data segment. Next, stack segment hold the 16-bit starting address of stack segment. Next, hold 16-bit starting address of extra segment. चलो नोट कर दो. Okay. Chalo. Now, so these are the basic registers. Okay. So next, if you see the other registers are this. SP stands for stack pointer, which is a 16-bit. Next, BP stands for base pointer, that is also 16-bit. Stack pointer represents the top of the stack. Base pointer represents the base of the stack. Next, SI stands for source index, which is 16-bit. DA stands for destination index, which is 16-bit. IP stands for instruction pointer, that is a 16-bit. And flag register also 16-bit. So now you can get the pairing here. So CS colon IP is a pairing. CS colon IP is a pairing. So now if you check, CS colon IP is a pairing. ES colon DI is a pairing. Data segment stack segment colon stack pointer is a pairing here, and data segment can be paired with SI. Data segment is paired with SI, source index. This is SI. Next, AX, BX, CX, DX. IP means instruction pointer. Flag register. So these are the major things. Make a note of this point. So these are base pointer. CS colon IP, DS colon SI, SS colon SP, ES colon DI, AX, BX, CX, BX, BP means flag register. So now flag register, these are the flag register. 8086 flag register, if you see, what are the 8086 flag registers? So these are the flags. Carry flag, parity flag, auxiliary flag, zero flag, sign flag, trap flag, interrupt flag, direction flag, overflow flag, and ornithology. So this is what we can write here. One day international, Tendulkar Sachin 0, all play cancer. So what we can write here? One day international, Tendulkar Sachin 0, all play cancer. One day international, Tendulkar Sachin 0, all play cancer. So total 9 flags are there. In the 9 flags, we're having 6 status flags, 3 control flags. Okay. So what are the status flags? We're having the carry flag. So what are the flags we're having? We're having the carry flag. Next, we have the parity flag, auxiliary carry flag, zero flag, sign flag, and O for overflow flag. This is for overflow flag. This is for overflow. So these all are the status flags. So 1, 2, 3, 4, 5, 6. So 6 status flags hai. 3 control flags. Control flags are for controlling the operation. They can control the entire sequence of the program. Okay. So try to understand that. So they are the direction flag, interrupt flag, trap flag. Direction flag means it is useful for auto increment or decrement of source index and destination index registers. So for example, if direction flag is equal to 0, means source index, destination index will be increasing automatically. If direction flag is equal to 1 means source index, destination index will be decrementing automatically. So one represents the auto increment, other one represents the auto decrement. So try to understand. Trap flag. If trap flag is equal to 1 means that is step mode. Program will be executing step mode. Interrupt flag आपको पता है. If interrupt flag is equal to 1 means interrupt is generated. Interrupt is generated means interrupt flag is equal to 1. So that is the sequence. This is the interrupt. Okay, done. So this is about the flag list. Now some of the instructions we'll see. Classifying the instructions. If you see the instructions, so these are the arithmetic. So explain the instructions of the 8086. Let us give a question here. So if you do model a question model, so what are the questions we can keep? explain the instructions of 8086. This is one question we can take here, and another question I can take like this question. Draw the 8086 flag register format. So what we can write here, 8086 flag register format. Next another question. These are different questions can be formed. Question: explain the register model, programming model of 8086. Programming model of 8086. Okay, programming mode of 8086 means you have to give the flag registers and all those things. Okay, next. Explain the block diagram of 8086. Explain the block diagram of 8086, or explain the architecture, we can say. Explain the architecture. 8086 with a neat sketch. Or the same question can be asked like this, or define pipelining and explain how it is implemented in 8086. Next. Question. Explain the minimum mode pins of 8086. Action. Explain the maximum mode pins of 8086. Yeah. Now let us take the instructions. See here. How these instructions are going to work? Just go through this. See here, arithmetic instructions. Let us take add instruction. As I told you, 8085 does not support arithmetic. 8086 supports arithmetic. So please remember this. 8085 does not support mul and division. Sorry, 8087 does not support mul and division. 8085 does not support multiplication and division. 8086 supports mul and division. Okay, so please note that point. Mul and division are not supported in 8085. So if you see the first, in immediate addressing mode, add AX comma 1 2 3 4. So AX will be added with 1 2 3 4. So this one is added with AX can be added 1 2 3 4, and the result will be stored in the AX. Next comes the register addressing mode. in the register addressing mode, this is add AX comma BX. Content of the BX will be added with the AX and the result will be stored in the AX. Okay, so that is the register addressing mode. Next, this is add direct addressing mode. So direct addressing mode la, we are going to give the specific address. So this is a 20,000. So at a distance of 20,400, so 0400 is effective address. 0400 is a effective address. 0400 is a effective address. So at a distance of 20,400, we're having a 44. So 44 is added to this. 20,400 plus 44 is added to this. Okay, so please make a note of these points. Noted? Chalo. Next, let us go for this register indirect addressing mode. That means first we are giving the SI register. SI register is having 4000. Add AL comma within the square brackets. SI means from the base address. So there is a base address. At the base address, the distance of SI. SI is equal to 4000. So SI value is equal to 4000. Base address is equal to suppose 20,000. So that is 24,000 will be. So 24,000 will be added. So 20,000 will be added to 4,000. So 20,000 plus 4,000. So I'm going to get 24,000. So 24,000 is the effective address. 24,000 is the effective address. Okay, 24,000 is effective address. So from that effective address, whatever the content is there, the 26 is going to come here. Okay, that's it. Okay, chalo. Next. So I was talking about the multiplication instruction, my dear. Multiplication instructions is not there, but here it is there. Mul instruction, if you see mul BL, the contents of the BL will be multiplied with the AL and the register will be 16-bit will go to the AX. Suppose if I'm saying mul BX, the contents of the BX will be multiplied with the AX and the result will be stored in the DX and AX. Why? Because this is 16-bit and this is also 16-bit, so total will become as 32-bit pair. So 16-bit multiplication with 16-bit multiplication, the result will be 32-bit multiplication. result is 32 bit, 16 bit, 16 bit. So next division. So I have given a program here, 8 bit multiplication program. So move AL comma 22 I have taken, move BL comma 11 I have taken, mul BL means 11 is multiplied with 22. So answer is coming 242. The 242 means the AL is equal to 42 and the AH is equal to 02. Next, mul BX, move AX comma 1111, move BX comma 2222, mul BX. So 1111 multiplied with this, 1111 multiplied with 2222. So I am going to get it as 2468642. 02468642. So when you are multiplying 1111 with 2222, you are going to get 24,68,642. 24,68,642. Okay, that is the point. 2468642. Okay, so that's how the multiplication instruction will work. So it's a 8-bit multiplication, it's a 16-bit multiplication. In 8-bit multiplication, the result is 16-bit, that is stored in the AX. And if it is a 16-bit multiplication, the result is 32-bit, that is stored in the DX and AX. That's how it will work. Okay, so next comes the division instruction. So this is the division instruction. Move AX comma 441, move BL comma 20. So divide BL. So divide BL is like this. 441 20. So 20 22 is a 440. 1 is a remainder. So this is the quotient. So this AL is the quotient and this AH is the remainder, my dear. AL is the quotient, AH is the remainder. So AL is this, AH is this. Okay, that's how it will work. Suppose if it is a 16-bit 32-bit na, so it will take 32-bit. Okay, chalo. That's it, enough for today. Some of the arithmetic instructions I have explained. Any doubts you can ask me.